Welcome to the world of computer simulations, where dynamic models illustrate changes over time. We'll explore how simulations define complex systems, their advantages over static models, and their ability to demonstrate temporal changes. Let's dive into the fascinating realm of computer generated insights. Computer simulations are dynamic models that replicate real world processes over time. Unlike static models, they can demonstrate changes and predict outcomes, offering a more interactive and insightful analysis. This adaptability makes simulations invaluable for understanding complex systems such as weather patterns or urban development by providing a visual and temporal representation of change. Video games like city building or farm management simulate real world dynamics, showing changes over time. Unlike static images, these simulations provide interactive experiences. Similarly, weather forecasts on television offer dynamic, real time updates, unlike static cloud pictures. Both examples highlight how simulations can model complex systems and predict future scenarios effectively. Studying real typhoons is risky and time consuming. Computer simulations offer a safe, efficient alternative. They function like scientific video games, using rules to model changes in storm paths or plant growth. This allows scientists to observe dynamic processes without waiting for real events, enhancing our understanding and preparedness. A computer simulation is a dynamic model crafted with software, illustrating movement and change. It employs mathematical and scientific principles to predict system behavior over time, from seconds to years. This allows scientists to explore complex phenomena safely and efficiently, enhancing our understanding of natural processes. Scientists begin by inputting initial data such as wind speed. They then define the scientific rules like how heat affects air movement. The computer uses these inputs to calculate and animate the system's behavior, creating a dynamic simulation that visually represents the event. Simulations are dynamic, illustrating processes in motion rather than static snapshots. They are predictive, offering insights into future events based on predefined rules. Additionally, simulations provide a safe environment to study hazardous or slow processes, allowing for risk free exploration and analysis. Playing The Sims at home is a simple simulation where characters' actions unfold over time. In schools, online simulations demonstrate planetary orbits, allowing fast forwarding to observe yearly changes. In the Philippines, the Philippine Atmospheric, Geophysical, and Astronomical Services Administration employs complex simulations to predict typhoon paths, aiding community preparedness and safety. Computer simulations are like scientific movies, crafted using specific rules. They allow us to observe changes over time, something static models can't achieve. The biggest advantage is visualizing action and the passage of time, providing dynamic insights into processes and phenomena. A scientist simulates mango tree growth over 10 years. They program rules. With sufficient sunlight and water, the tree grows zero point 0.5 meters annually. The simulation compresses this decade long growth into a minute, visually transforming a sapling into a mature fruit bearing tree. A city planner in Manila tackles Epifanio de los Santos Avenue traffic by simulating virtual cars, buses, and traffic lights. They test solutions like new bus lanes or adjusted light timings. The simulation reveals potential improvements or setbacks, guiding the selection of the most effective plan before costly real world implementation. A common mistake is confusing simulations with videos. Videos depict past events, while simulations use rules to predict future scenarios. Similarly, a three-dimensional model is often mistaken for a simulation. A three-dimensional model is static, like a rotatable image of deoxyribonucleic acid, whereas a simulation demonstrates dynamic processes such as deoxyribonucleic acid replication over time. SMART is a mnemonic to remember that simulations show movement and real time. Think of them as a crystal ball for scientists using math and computers to predict outcomes. Unlike static models, simulations dynamically illustrate processes, offering insights into potential future scenarios. Special effects in movies, such as the massive waves in The Perfect Storm, are crafted using computer simulations. Artists and programmers employ physics simulations to create realistic digital water, fire, and explosions, enhancing the visual storytelling experience. Scientists and engineers use simulations to test ideas safely and cost effectively before real world application. Weather forecasts rely on simulations explaining why predictions change with new data. Understanding this is a step towards creating simulations to address community issues. Computer simulations are dynamic models illustrating change over time. Unlike static models, they effectively demonstrate movement and predict future events. Scientists leverage these simulations to explore phenomena that are otherwise too large, small, fast, slow, or hazardous to observe directly, enhancing our understanding of complex systems.